everyone. In this video, I wanted to spend some time walking through some upgrades that I got to do in my home lab recently. Now for reference, outside of all of the networking gear that I run in my home lab, on the compute and storage side of it, I've been running with a Synology NAS and a 8-year-old PC that's been running my VMware ESX environment. So with a lot of the more intensive stuff that I tend to be running in my home lab lately, I wanted to pick up something a little bit beefier than my 8-year-old mini PC. And while I do have a full Cisco UCS C220M4 sitting in storage right now, I tend to only want to pull that thing out when I actually have a lab that's going to make use of all of the power that I have running in it. So I wanted to find something that was a little bit more low power, something I could leave on all the time, kind of like my existing mini PC, but something a little bit more modern than, 8 years ago. So after doing some research and spending some time digging around on what would be the best option, I ended up deciding on picking up a pair of Intel NUC11s. Now, I originally wanted to go with the Pro version, but due to supply chain and all that fun stuff, I wasn't able to get my hands on any of these for a couple of months, and then finally got some of the performance models that came into stock, so those are the ones that I ended up with. So the purpose of this video is going to be, in some aspects, a tutorial as we walk through some of the config and setup that I do, but mostly it's just going to be kind of a ride-along for showing what I did in my home lab. Here's the upgrades that I completed and how I accomplished certain things, and maybe a little bit of background as to why I did certain things. So with that said, let's go ahead and get started. Just to walk through all of the different components and everything that I picked up for the build out. Like I mentioned, I did end up picking up 2 of the Intel NUC11s with the i7 processor. These are mini PC kits with no insides included, so RAM, hard drive, and all of the accessories and stuff like that you have to pick up separately. So to complete the build, I picked up 2 1TB Samsung 970 EVO Plus NVMe drives. I also picked up 2 64GB memory kits from Crucial. And to top it all off, I also picked up these Ethernet adapters, which might require a little bit of additional explanation. So the Intel NUC11s come with a 2.5GB Ethernet port on the back. They only have one of them, so if you want any additional Ethernet ports or connectivity, you'd need to buy some sort of USB adapter, which I ended up picking up. Part of my thinking with this too was that since I actually have quite a handful of devices in my lab that have 2.5GB ports or 10GB ports, but I only have a switch that's capable of 1 and 10GB. I don't have anything that's capable of those mgig speeds like 2.5 or 5GB. So what I thought I would do with these Intel NUCs was get 2 1GB Ethernet adapters, use those as the uplink ports from the NUCs themselves to my network switch, and then I'd use the 2.5GB Ethernet ports that are natively in the devices themselves. I would just connect those back to back and use those for vMotion, since that'll benefit more from being able to leverage those 2.5GB speeds. Now the caveat to that, unfortunately, is that VMware doesn't natively support those Ethernet adapters, nor does it actually natively support the 2.5GB Ethernet ports that are on the back of these Intel NUCs today. So we will have to load some custom drivers to get these things to work, which we'll focus on a little bit later on in the video. Okay, now that we've walked through that, I'll go ahead and shut up for a couple of minutes and we can go ahead and get to the build. Now that the build's completed for both of those tiny PCs, the first thing that we're going to have to do is create a bootable USB drive to load ESX on the Intel NUCs. Now, I did mention earlier that by default, the 2.5 gig Ethernet port that's in either one of those devices is not natively supported in ESX. So we're going to have to download a community driver, which I show here on the screen. This will add support for those 2.5 gig Ethernet adapters. So we're going to have to download this and load it manually into the bootable ISO so that when ESX comes online, it's able to properly identify those adapters and we can use them to get up and running. So now that we have that, we'll jump over to PowerShell real quick. And we'll go ahead and use the VMware image builder, and we'll start off with import-module vmware.imagebuilder. And then we're going to add the VMware repository for all of the different software images. So we'll do add-ESX software depot, and then the URL to the VMware update website. And once we did that, we can do a get-ESX image profile, and this is going to list out all of the potential ESX images that we can download and modify for our custom image that we need to build. And this takes just a second. Once that's done, we're actually going to go with a ESX 7.0 update 2 image. So we'll go ahead and download that, and we'll use the command export ESX image profile, -image profile, and we'll pass it the name of the image that we want to download. And then we'll do an -export to bundle and provide a file path for where we want to download it locally. And we will be downloading that to a zip file. Once that's done, we can do a dir to make sure that we do have both the community driver that we downloaded as well as the new ESX image that we pulled down. And so we'll go ahead and tap up a couple of times to get back to that add ESX software depot command, and we'll modify that to remove since we no longer need that image repository. And next, we'll actually change to our local ESX image that we downloaded as the software depot. So we'll do an add ESX software depot again, but this time passing our local image. And this is where we'll start to make changes to the included packages. And so then we'll also use the command add-ESX software depot for our community driver. And now we can start building our new image. And we'll do that using new-ESX image profile. And we'll specify the profile that we want to clone, which is our original 7.0 update 2 standard. And we'll create a new image called 7.0 update 2, and we'll add a -custom NIC at the end. And we'll go ahead and set a vendor to 0x2142.com. And so we can real quick double check that we have the correct software depots connected at the moment. So we can do a get-ESX software depot, and that'll show that we have both our local zip file for the ESX image as well as our community driver. And if we need to figure out the package specifically that we want to add to our custom image, we'll use the get-ESX software package command. And this will list out all of the different packages that we can pull from either one of those software repos. And a little bit up towards the top, we can see that net-community package. That's going to be the package that we need to include in our new image. And so to do that, we'll do add-ESX software package -image profile, and we'll add our new custom profile name, which is the ESX 7.0 update 2 -custom NIC. And then we'll add the software package net-community. Last but not least, we can go ahead and export this to an ISO file by doing export-ESX image profile, passing it the image name of our custom build that we just made. And we're going to do -export to ISO and pass it the file path, which will be localfile.iso. And again, once that's done, we can do a dir command to double check that all of the images and everything are local. So with all that's done, we can go and open up Rufus, which I'm going to use to go ahead and burn that USB drive. We'll select our custom image and then go ahead and hit start. It will prompt to confirm that I want to wipe all the data on my USB drive, which I do, so I'll hit OK. And this will create our bootable flash drive in just a couple of seconds. Okay, once all that's done, we can hop over to installing ESX on the Intel NUC. So first thing I'm going to do is I'm going to boot up into the Intel BIOS. I want to double check that both my hard drive and memory and all that are recognized correctly, which if we look real quick, it does look like we have total of 64 gig of RAM. And if we go over to the advanced tab under storage, it looks like under our M2 slot, we do show that Samsung 1 terabyte NVMe drive. So the other thing I wanted to check was I did want to check the processor settings. So first we'll go over to performance and we'll scroll down to processor. And I wanted to double check that hyperthreading and all the relevant settings here are enabled, which they should be by default anyways, but doesn't hurt to double check. And next I wanted to double check that the virtualization features that I need are also enabled on the processor. So we'll go ahead and jump over to the security tab real quick and then down to security features. And sure enough, as I expected, the Intel settings for virtualization are enabled. And so with all that good, let's just go ahead over to the boot section real quick and double check our boot priority to make sure that the USB drive is going to be the first choice of boot options, which in fact it is. So with all that, we can go ahead and hit the X in the corner since we didn't actually change any settings and reboot into the VMware installer. As we're walking through this, one other thing I wanted to kind of call out was that in no means am I an expert on VMware or ESX. I did some VMware administration work, but it was probably about 8 years ago, so it's been quite some time. These days, most of the VMware and ESX stuff that I do tends to just be in my home lab. So all that being said, just a fair warning that anything I'm doing here might not necessarily be best practice or even recommended by, VMware or someone who's certified or does this on a daily basis and knows what they're doing. But this is just kind of the way that I'm setting it up for my lab and, suits the purposes of what I'm trying to accomplish. Once the installer finishes loading, we'll get this Welcome to VMware ESX 7.02 install screen. And it's a little bit hard to see because of the contrast here, but it does ask us whether or not we want to install the image or not, and we'll go ahead and hit install. We'll have to accept the license agreement, so we'll hit F11. Next, we want to select which drive we want to install the image on. Right now, it's only going to show my Samsung NVMe drive that I want, as well as the USB drive. I do want to install this directly on the NVMe drive, so we'll select that. We'll go ahead and keep US default as the keyboard layout, and I'll configure a root password. Next, we will get a quick warning to confirm that we want to wipe all the data on our NVMe drive and install. But since this is a new system and everything looks good, I'll go ahead and hit F11 to go ahead and proceed with the install. This install actually runs surprisingly quick on this tiny little NUC. So just a couple of seconds and it'll be done. Once the install is complete, we will get a quick screen that says that it's been installed successfully and go ahead and press enter to reboot, which we will do. After a quick reboot, we'll be taken to the ESX 7.0 console. Right now, this box is only sitting right next to me as a temporary staging thing while I set it up. So it's not actually connected to the network or anything like that. So we'll go ahead and pre-configure just a couple of settings so that when I move it over to its final resting place, it'll have network connectivity and we'll be able to connect to it remotely. So we'll go ahead and hit F2 to customize system and type in the root password that we configured earlier. The first thing I'm going to go to is down to Configure Management Network. And for network adapters, right now we show VMNIC 0. This is only that 2.5 gig Ethernet adapter that's built into the NUC itself. I haven't actually connected the 1 gigabit USB adapter. And the reason for that is actually because we will need to install a separate community driver for the USB Ethernet adapters. And I wanted to show how you can do that directly on the ESXCLI itself. So I wanted to show that a little bit differently than, loading it into the image as we did earlier. So since that's the only network adapter, we don't need to select which one's going to be our management adapter. We'll use that for now and we'll change it out later when we're ready. Next, I do want to drop down to the VLAN config and set that to VLAN 2. And then we'll drop down to the IPv4 config, set it to static IP address, and I'll go ahead and enter in the configuration that I'll be using for this device here. I'll also go ahead and then drop down to the DNS configuration, add my primary DNS server, which I have local, as well as the host name, which is going to be 0xVM04. And then for custom DNS suffixes, I use 0x2142.local in my lab. Now, unfortunately, at this point in the recording, I actually had my video cut out, so I didn't get to show it here. But the only other steps we'd need to do is go ahead and hit escape to exit this, save the networking config. I think it does normally prompt you to restart the management network at that point in time, which we can go ahead and say yes to since it's not connected. And then last but not least, we went back to the main ESX local GUI screen and shut down the system. So once I got the box moved over to my lab, hooked up, connected, and all of that, I powered it back on. And after a couple of minutes, we can reach the web interface to begin configuring the box locally. So I'll go ahead and log in with the root password that I created earlier. And again, real quick, if we just look at the main screen for ESXi, we can see all the correct information showing in here. So we see that our memory does show the 64 gig of RAM. And we can see we have just over 800 gig of storage free after the install. And so the first thing then we're going to do is we're going to go ahead and jump over to the networking tab. And again, I wanted to point out that right now we only have that vMNIC0, which is going to be our 2.5 gig adapter. And if we click on the adapter, we can see that the supported speeds do include that 2.5 gig. So that adapter is being identified correctly, and we're able to leverage the 2.5 gig speeds that it offers. And so to get the USB Ethernet adapter working, we're going to have to load in our custom community driver for USB network adapters. So again, on the screen right now, I'm just showing the web page for it. I'll have a link to this driver in the video description if you need to reference it. And so I'll grab the image I need for ESX 7.02 and hit download. And so to install this, I'm actually going to upload this to the local data store. So we'll jump over to Storage, Data Stores. I'll click on Data Store 1 since that's the only one that we have configured right now. And then I'll click Upload, grab my community driver, and allow that to upload onto the local ESX box. Once we're done with that, in order to install this community driver, we're going to need to SSH into the ESX server. And so first we'll have to go and enable the SSH service. So we'll go under Host down to Manage, over to Services, and then I'll search for SSH. And once we find that, we'll select that service and hit Start. So I'll quickly open up a PuTTY window. And by default, this is going to drop us into the root directory of our ESX machine. And so we can double check that we can access our community driver by doing an ls/vmfs/volumes/datastore1. And sure enough, we can see the contents of that drive, which include the driver that we just dropped into that directory. And so we'll go ahead and install this driver using the command ESXCLI software component apply -d and the full path to our community driver. Pretty quick, that'll give us the installation results saying that it did install the new component, but that we need to reboot the machine for that driver to take effect. So we'll jump back over to our ESX host real quick. And on the main host page, we actually do also now get a warning saying that the host needs to be rebooted to complete the configuration. So we can actually click the little action icon if we want to and click reboot. And it'll warn us that the host isn't in maintenance mode, but I don't have anything running on it right now, so I'll just go ahead and hit OK. So after a couple of seconds, our ESX server is back online. We'll go ahead and log back in and drop over to the networking tab. And sure enough, under physical NICs, we not only have our vMNIC0, but we also have a vUSB0, which is our USB adapter that we just installed. Now, before we configure our 2.5 gig Ethernet adapter for the vMotion traffic, the first thing I will need to do is switch my current management NIC from that 2.5 gig over to my 1 gigabit USB adapter. And so we'll do that by going over to the Virtual Switches tab. I'll click on my vSwitch 0 and hit Edit Settings. And then under Uplink 1, I'll change that from vMNIC 0 to vUSB 0 and hit Save. And then in the background, I'll go ahead and swap that Ethernet cable for my management network from that 2.5 gig port into the 1 gigabit USB adapter. Okay, now that we have both of the network adapters finally connected, we're going to go ahead and configure those 2.5 gig ports for vMotion traffic specifically. I'm going to go ahead and click Add New Virtual Switch. I'm going to name my new switch vMotion. And I'm going to go ahead and select the vMNIC 0, which is the 2.5 gig Ethernet adapter. And then I'm going to jump over to port groups, create a new port group, which I'll call vMotion only. And I'm going to give this a VLAN ID of 40. Set my virtual switch to that new vMotion specific virtual switch that I created. And then after all that's done, I should be able to hop over to the VM kernel NICs, add a new VM kernel NIC. I'm going to select my vMotion only port group. I'll keep all of the settings the same, except I'll drop down to TCP IP stack and select vMotion. Now that the networking configuration is all sorted out, the next thing that I need to do is connect my new ESX hosts to my existing iSCSI LUNs that are hosted on my Synology NAS. So we'll go ahead and do that by jumping over to storage and then hit adapters. Then we'll hit software iSCSI and we'll change this to enabled. And the first thing I'll do is I'll go ahead and drop down to static targets. I'll click add static target. I will copy and paste the target name from my Synology NAS, as well as putting in the IPv4 address that it's reachable at. Next, I do have CHAP authentication enabled, so I'll go ahead and jump up to that, change the setting to use CHAP, and then enter in the username and password for that authentication. Once that's all done, I can go ahead and hit Save Configuration. And then real quick, before we jump over to the Synology side, I'll just hit Rescan and refresh. On the Synology side, I'll open up my menu and go down to SAN Manager. And then I'll drop down to Hosts. Now, with the newer versions of Synology lately, they actually make this process a lot easier. So then I'll just go ahead and click Add to create a new host. I'll add my name, ESX04. I'll add my description, which is Intel NUC11. Operating system I will keep as VMware ESX. And sure enough, we do see that our iSCSI initiator from the ESX host has already attempted to connect to the Synology NAS. So I don't have to enter any information here. I can just go ahead and select that and click Next. On this next screen, I can assign permissions to the different LUNs that I have configured. I only have 2 that I'm using primarily these days, and this host will need write access to both, so I'll leave the permissions at read-write and hit Next. And then on the final screen, it will prompt us to confirm our settings, which everything looks good, so we'll just go ahead and click Done. Now that that's configured, we can jump back over to the ESX side again, and we'll rescan the iSCSI adapter one more time. And over on the Devices tab, we can see that we have a connection to the Synology device over iSCSI, which means if we drop over to data stores, we should see both of those show up, which we do. So now that all of the local device configuration has been done on the ESX server itself, we can hop over to my lab vSphere machine and add it into vSpheres for centralized management and updates and all that fun stuff. So I'll go ahead and log into vSphere. And I do already have one of the 2 Intel NUCs already configured and added into here. And I already have a cluster configured called 0x2142-HomeLab. So we'll go ahead and right click on that and add a new ESX host. Okay, and so then we'll be prompted first to provide the hostname and/or IP address of the new machine. So I'll go ahead and put it in. Next, we'll be prompted to provide the username and password that'll be used to connect to that machine. So I'll use my root user and the password that I configured earlier. Next, we'll be jumped onto the host summary screen, which will just help us kind of confirm what we're adding. Everything looks good, so we'll go ahead and click Next. Then we'll be prompted to assign a license, so I'll go ahead and assign the proper license for ESX7 here, and click Next. For the lockdown mode options, I'll go ahead and keep this as disabled. And then for the VM location screen, I won't go ahead and change anything for now, and I'll just hit Next. And finally, on the ready to complete stage, everything looks good, so we'll go ahead and hit Finish. And after just a couple of quick seconds, the new ESX server has been added. Now, as a final thing to show off real quick, I thought it would be fun to show doing a vMotion over those 2.5 gig ports. So what I'm going to do is bring up the ESXCLI here, and I'll use the ESX top command, and then press N to switch over to the networking view. And what this will allow us to do is watch the network usage in the middle of the vMotion to see how much throughput we're getting across that 2.5 gig link. And so we'll jump back over to vCenter real quick, where I have a test Linux machine that I built. This box has an 8 gig thick provisioned hard drive that's actually on local storage. So it's on that local NVMe drive on the Intel NUC. And we're going to do both a compute and storage vMotion. So it's going to copy the entire thing, including that 8 gig disk over the 2.5 gig port. So go ahead and right click that VM and click Migrate. We'll be prompted for the type of migration. And again, I said we are going to do compute and storage. So we'll select that and hit Next. First, we'll be asked for what compute node to move it to. And I will move this to the new ESX host that we just built and then click Next. Then we'll be asked for where to place it storage-wise, and I'll go ahead and just put this also on local storage. So we're going from NVMe to NVMe over that 2.5 gig Ethernet link. Next, we'll be prompted to change any network settings if needed, but I am moving this from an internal network on one side to the internal network on the other side, so no changes are necessary. So then we'll go ahead and hit next. Last but not least, we'll be given the ability to change the vMotion priority. I'll just leave this at the default and hit next, and then we can go ahead and click finish. So if we hop back over to that ESX top view real quick, so this console is actually running on the ESX host that is receiving the vMotion migration. So if we look under the megabit received over on the fourth from the right side column, we can actually see those speeds pretty quickly ramp up to 2.5 gig, which is exactly what we were hoping to see. And since this is only an 8 gigabyte disk, after a couple of seconds, that entire VM is migrated successfully from one host to the other. Okay, and with that pretty much wraps up everything that I wanted to show with my home lab upgrades. Now that's left for me to do is go ahead and move some of the old VMs off of that 8-year-old ESX host that I have running and start spinning up all my new fun stuff on these two new Intel NUCs. So with all that done, I hope this video was fun. Thank you so much for watching, and I'll see you next time.